In this lesson, you'll learn proven strategies for cases where the module's actuator command doesn't result in the expected system response. We'll show you how to separate command circuitry, scan data interpretation, and real-world output. You command an actuator, maybe a relay, solenoid, or valve, using a scan tool. The tool reports commanded on, but nothing happens at the actuator. Why can the ECU show the command, but the system stays silent? Understanding this mismatch is crucial for effective diagnosis. Modules track internal logic. They know when they've sent a command, but unless there's feedback, they often cannot tell if the actuator physically did its job. This is why the scan tool may show a valid command, even though the output pin, wiring, or actuator is open or failed. To diagnose the cause, measure at the load. Use a multimeter or test light at the actuator connector. Is power present with the command? Is ground switching? Measure both sides of the actuator to reveal whether the command is reaching the real world. Compare scan tool live data for commanded state with direct measurement or actuator feedback when available. A mismatch between scan data and measured voltage or actuator movement points to wiring faults, output driver failure, or an open in the load circuit. When the module commands the actuator on, you should measure expected voltage or continuity at the correct pins. Lack of expected readings confirms an open, high resistance, or driver fault. Always reference voltage at both the actuator and the controlling module output. Never replace an actuator or ECU just because the module shows a commanded state on a scan tool. Many circuit faults, like open wires or bad grounds, leave scan data looking normal. Always test voltage and continuity on the actual circuit to avoid guesswork and comeback jobs. A stepwise approach. Command the actuator with scan tool, measure output voltage at the module and actuator, verify ground and power integrity under load, and check for feedback signal if present. This method isolates opens, shorts, driver, and actuator defects. When command and response don't match, scan data alone can't be trusted. Always measure real circuit voltage and continuity at the actuator and controller. This approach exposes wiring, contact, and output device faults before you ever touch the parts bin. You've learned how to properly confirm actuator command failures and isolate faults the right way, using proof, not guesswork.